So welcome to this class. In this session, we are going to discuss about some rule for counting. So let's take the rule. So suppose that a task can be done in one of the N1 ways, in one of N2 ways, up to or in one of NK ways, where none is very key. None of the sets of Nj Ni ways of doing a task is the same as any of the Nj ways for all pairs I and j with 1 less than or equals to I less than j less than or equals to k, then the number of ways to do the task is N1 plus N2 plus N3 up to plus Nk. So note the difference between the statement for product rule that we stated earlier and the sum rule. So the key thing here is that there are different ways of doing the job, but then there's no relationship between one of the ways of doing the task and the other one. So therefore, you say that the task can be done by simply adding these possibilities of this number of ways of doing that given task. So example, so suppose that either a member of the mathematics faculty or a student who is a math major is chosen as a representative to a university committee. How many different choices are there for this representative if there are 7 members of faculty and 83 math majors and no one is both a faculty member and a student. So what makes this question to be different from what we did in the previous class is this condition, and then there's also another keyword, none, this keyword here. So therefore now we say solution. There are 7 ways to choose a member of math faculty, but there are only 7, and 83 ways to choose a student who is a math major. Choosing a member math faculty is never the same as choosing a student who is a math major. That should be very clear. So because no one is both a faculty member and a student, then some rule applies, and we have that 7 plus 83, which is 120 ways of picking a representative. So that's what we have. And lastly, number 2, a student can choose a computer project from one of 3 lists, and then the 3 lists contain 23, 15, and 19 possible projects respectively. So no project is on more than one list. So how many possible projects are there to choose from? So in this problem, this is one of the keywords. No project is on more than one list. And then a student can choose a project from one of the three lists. So therefore, the first thing that you have to consider here is that the student can choose a project by selecting a project from the first list, or the second list, or the third list. And because no project is on more than one list, then sum rule applies, and we say the possible ways we have 23 plus 15 plus 19, which is 57 ways to choose a project. So that's what we have. So in the next session, we'll demonstrate how we can combine both the product and the sum rule on counting problems. So thank you.